Welcome to our demo for faster and easier reporting from healthcare software. So this case study is regarding with healthcare software. And in this module, we'll be looking at processing more and more information using the PC and server RAM. So what is the value proposition? We are looking to eliminate cubes. We are looking to eliminate the joins between the last transaction tables. And then we are looking to remove the complexity of understanding for SAP, Tally, HIS, and other source systems. We are also looking to reduce the extraction times, the business logic coding time, the maintenance times with the ETL tool. And most of all, we are looking to reduce the BI tool costs and implementation costs, the length of the SQL code required to make the reports, and the reporting data size. The reporting data size has to be made very, very small. Now, we are looking to reduce the ETL development times and ETL development costs, which is where our ready-made module for data services comes into picture. And at the end of this process, you should be able to make highly complex reports very quickly at the database level with minimal data refresh short times. We're looking to raise the ease of reporting. You should be able to work with BI stack of tools. You should be able to handle large data loads, right? And other things. So at the end of this process, you're looking at lower coding time because it's a ready-made template, faster data access, and then, get time series analysis. And this is in brief going to be the benefit slide. This is the benefit of a data warehousing. That means we reduce 100-page report down to 1 page of report. So if 100 pages of report is reduced down to 1 page of report, then because of data compression and code reduction, you can get maximum number of, you can actually scan their you can scan the pages in a minimal amount of time and then get reports with minimal refresh times. So with this then, sir, and this is what our whole endeavor is, that how do you minimize your extraction, transform, and load times so that your report reload times becomes maximum. This is in brief going to be the structure. So we would be extracting the data onto the staging layer, and then from staging layer, we'll code all the business logic onto the ODS layer. Now, in this particular demo, what we would be looking at is that within the ODS layer, how do you handle the type 1, type 2 entities, right? So this is a normalization layer. So we're assuming that from your staging to the ODS layer, your business logic has already been pre-coded. And from getting the data onto the staging layer, you have also done the same. But within the ODS layer, then how do you handle the type 1 and type 2 entities and also the type 1 and type 2 dimensions? This is within SAP Data Services. So this is what we would be looking at. Right. And of course, you should get sample dimensions, group by and whereby clauses and the fact tables. So with this, sir, I'll come down to my core demo, which is of initial and incremental data load for this thing. So you have to follow this particular document, which I will be doing it. Now, in this particular project, we had certain base tables and history tables. So base table is any table in the ODS layer or in the data warehouse layer where no history is maintained. That means I simply have an update. But a history table is that table wherein a certain history is maintained. So you have history making attributes and you have non-history making attributes. In case of non-history making attributes, you simply have an update. But in case of an history making attribute, your history was captured in the following way. And the history was captured by using what we call an effective from and effective to timestamps. Right. So, in this particular case. So, and we have to also handle inserts, updates, and deletes for both the events. That means in the base tables and the history making tables, you should be able to handle the inserts, updates, and deletes. So this is the matrix which you are looking at, the history making attributes of scenario 1, scenario 2, scenario 3, scenario 4, scenario 5. This is how you need to read this particular document, right? Now what happens is, if I look at scenario 1 and scenario 4, that means it's this scenario, simply handling the history, this thing insert, where you have a history making attribute or a non-history making attribute. So then I come down to here. In case of scenario 1 and scenario 4, you can have a case wherein you have a business key present in the data warehouse, or in case the business key is not present in the data warehouse, it's a straight case of an insert. But in case there has been an update, then we are going to generate an, in case of an history making event and there has been a change, then for the new historical event, we will be generating a new record. Right. Now, in order to handle the insert case, what we have done is we have used a query transform, we have used a validation transform, then we have handled query insert, then merge, and then surrogate key generation. So I will be looking at it from the SQL transform. So in your SQL, when we are using this kind of a procedure, then at a certain stage, in the last stage, you come down to what we call the merge transform. So I have this is my target, this is my source, this is my composite key. And then when not matched with the target, then I'm doing an insert of these particular values. Right. So this logic remains the same for both historical and non-historical events. I'm actually looking at converting your merge transform in SQL Server onto how would you do it in data services. Any questions up till now? Sumit? Hi, Sumit. How are you? Good morning, sir. Sumit? Hello? Okay, so any questions up till now? So I'm actually looking at converting these particular SQL transforms onto how would you convert it into the data services transform. So this is my normal, data service. This is my normal SQL transform, and then we are going to be looking at taking it up. So within the data services transform, I have say a source table and this is my target table. So your source table is here and this is my target table, and this target table has got two components. One is for handling the inserts and the second is for handling the deletes. Now in the query ID is what we are looking at is whether my composite key is there. So in your SQL transform, you're basically doing this particular match and then looking up for the surrogate key. So that is actually going to be done by using the lookup transform in your query ID, which I will elaborate at a later date. Then I'm going to validate whether that surrogate key is present in the target table using what we call the validation transform. If that surrogate key is not present, that means if there is a null and if there is a pass, then I'm inserting it, right? And I'm adding a load timestamp details here, and then the merge, and then this is the surrogate key generation. Now we have a surrogate key generation transform within data services. In your SQL Server, it will be replaced by what we call an identity column. Right. So this is in brief my template by which I will be looking at inserts from within the data services. So I'm going from a SQL data warehouse. So within the SQL data warehouse, how do you exactly go about migrating it onto the data services? Right. And the second one which I'm looking at is, so now I go down here. Right. So first of all is you're going to look up for the business key in the data warehouse table. You're going to check whether the business key is null or not using the validation transform. And then in case the business key, then it's a straight case of an insert. Right. And then you can use an insert timestamp or an update timestamp, and then effective from and history start timestamp, effective to as the end of the time. So you're going to be this thing. So this is going to be handling the inserts in this case. Now, in case you have history making record, so in case you have a history making record and you have to do an insert, that means I have an effective from and an effective to timestamp, and then I am adding a new row. After my history making event has been changed. Okay. Then we have a second flow here, which we had to handle it. And this particular flow is going to come from here. So I'll go up here. And I look at this particular transfer. Now, what we need to do is I'm looking up for the surrogate key in the query ID. I'm doing a validation. Now my composite key is present in my target table data warehouse, right? So this validation actually will say, yes, it is there. Now my table comparison transform is going to do the same function as what a merge SQL transform does here. Correct. So here it is going to say when matched by target in the in this particular case. Now what happens is the table comparison transform then thereafter releases your outputs in three formats. It can release an output in form of an insert, update, or a delete. Correct. Now, in case it's a delete, then it goes on to what we call a map transform. That means this will have the inputs of the deletes and which will be then converted to normal. And after that normal, this thing. So the way the map transform works is that you take a particular input from the table comparison, the history preserving transform. It is either insert, update, delete, or normal, and then convert it into whichever form output format you want. Then that normal format is then fed into the query transform, and thereafter the insert is going to happen. Now, in case it's in case of an update, because insert is going to be straight away handled later. But in case it's satisfies update, then we go on to what we call the history preserving transform, wherein we check the comparison with the history making events. In case of the history making events are there, then in case of an insert, then it takes this particular route. In case of an update, it takes this particular route. So this is going to have an input of an insert, which will be then converted into an output format of normal. Then in the query history insert, I will change the timestamp because we needed to load the timestamp. Yes, so Sumit, we'll be sharing in the late. So we have given a certain background of the particular project. So I will be sharing the video recording of it also. But if you follow this particular template, then for most of your data warehousing projects within data services, then you should be okay. So we had basically taken some 50 or 60 or 70 data warehouse tables, use this particular template and loaded the entire data warehouse. So what we are doing in this particular demo is, that we are looking at it in terms of the SQL transform, how you would convert a data services, because most of you would be conversant with what we call the SQL transforms. Those of you who understand SQL, then how does it map it onto the data services is what we are looking at. Right. So I have handled the first case wherein there is a composite key. And after the composite key, you look for the surrogate key and then do a particular insert. But then when it is matched by the target, when there is a particular, when it is matched by the target, right, that because this composite key can be matched, then I have to look for whether there is an insert, update, or a delete. So table comparison will release three kinds of output: insert, update, or a delete. And then the deletes will go into this case, and inserts and updates will go to the history preserving transform. And there from the history preserving, it will again capture the inserts. So I'm going on to this particular inserts case when there is a history mapping transform. So map the insert row as normal and discard all the other rows to the use of the map transform. And then you merge the output from flow one and then generate the surrogate key after the union option. Right. Any questions up till now? Sumit, any questions?
No, sir.
Okay, fine. Now, sir, I have the third scenario. Your query ID is not null, and we have the history in the start date and the end times, right? So this is what I have told you, that this shall help whether there is an update. Now, in case there is an update, I go down here. Now, right. Just 1 second. Just give me a second, please. I just lost the flow actually. Okay. Now I come down to how do you handle deletes? So within the data integrator, you can also map deletes. So deletes, in case you have a particular delete, then after this table comparison, you will get a delete transform. Then that will be mapped onto normal. It will go to query underscore delete, and then you'll be merging it onto. Yes, so within the SCD type 1 doing example, what will happen is you will simply do a table comparison because there is no history transform. So you will do a query validation and then simply remove the history preserving row and then go for it. So after query ID validation, you simply have the table comparison, and within the table comparison, you will, because either it is not there or the table comparison will either have an update or a delete. Is it correct? So in case of it's an update, then you use this particular update mapping operation, use the update then you update your the load which is there, and then you insert it into the target table. Now I go down here. Now I'm going on to how the map transform works, right? The map op transform. So you have a certain input row type. So you have a normal, update, insert, or delete. And then the output row type is, you can actually define how it is going to be. So again, it's going to be normal, update, insert, delete, or you can discard a particular row. So this is how the map actually transform actually works. So this is how you'll be handling the same. Now, if you are having a case where there are non-history making attributes, there's a scenario 5, because this is the case wherein you do not have an SCD1, sorry, SCD2, you have an SCD1 case. So in case you have an SCD1 case, you have to handle the scenario number 5. In case of a scenario number 5, what we did was we took the source table and the target table, we validated it, and then in case it's of a fail, then we did a table comparison. That means we found whether there was an update or not, because if validation is successful, that means it is null, then it's a straight case of an insert. Then we did a table comparison, and after the table comparison were done, the only output which we got was what we call an update. We took the update, then update rows, then converted them into normal. Then within the query transform, we then loaded the load timestamp, and this is a normal. So now what is going to happen is, in your target table, the update has to go. Then again use the map transform to convert the normal into updates and then load it onto the target database. Any questions up till now on this? Okay. So then I now go to the next stage. So again, now in order to actually, because there was a particular case wherein any questions now up till now? Hello, Sumit, Amrita, any questions?
No.
Okay. Is the demo clear up till now?
Yes, sir.
Okay. Now,
sir, are you sharing the screen?
Yes, sir, I'm sharing the screen now. You're not able to see the screen?
No, I only see your name, MM.
Amrita, are you able to see my screen? Hello, Amrita, are you able to see my screen?
Yes, sir.
Amrita, are you able to see my screen?
Yes, sir.
Okay. Sumit, you will have to, I'm just pausing the record. So now, sir, I'll just go down here. So now, sir, we have had, so you have to segregate this whole thing into various portions, right? How do you handle deletes? So a delete will simply come from table comparison. And in order to load the timestamp at which a particular delete has happened, you'll have to take the table comparison output, use the map transform to convert the delete inputs into normal, then put it into query transform, load your timestamp, then again use the map transform to convert the normal into deletes, and then load it onto target tables. This will be the same for history making and non-history making. Inserts I've handled in both the cases. You simply look at inserts. Basically, there are two cases. One is the surrogate key is not present in the target table. So then it's a straight insert. So after the validation transform, you basically after the validation transform, there is this thing. So then you add the load timestamp and then you put it onto key generation, and you insert. Now, this is the case for 4. But in case of 1, in case there are history making attributes, I need to add another layer. Then your output from the table comparison should be insert. So the output from the table comparison should be update. Then it is fed into history preserving transform. And after the history preserving transform, from the history making events, if it's an insert, then it goes into the, and then it is basically automatically inserted. Now I come down to the next stage, wherein we'll be looking at type 1 and type 2, right? So this is how you use the map transform, right? Update in the map. Now this was the case wherein the scenario 5, this particular scenario 5 is going to be handled, that in case there are non-history making attributes, then how do you handle updates in them? So for that, actually what we had done was we had made a separate data flows, because in which case I had a query transform, I validated. That validation failed. That means that surrogate key is present. It went into table comparison, took out the updates here. That update is converted to normal. And then after the normals is there, then we update the load timestamp, and then we use the map operation to insert it into the target database. Now, what happens in this particular script? So I need to capture the incremental data load, right? So incremental data load is what I need to capture is that from my last load timestamp in the data warehouse, I need to be able to capture what are the changes which have, I need to capture only those data from the source database, which is after my target tables data warehouse. Now, in this particular case, we had used a data services script. So if you see in our initial demo, we had shown you what we had called the staging layer. So if I go here, this is my staging layer. This particular staging layer is going to be truncate and delete. That means it will capture only the data which is after the last load timestamp. All right. So, and in order to do that, we have used this particular script, right? That means in case the process of full load is set to begin, so I have to do one and initial load and one and incremental load. Now, once I was to do the full load, then I had to set up my last load timestamp to a particular date. Otherwise, the comparison will not take place, right? So we made a script here. So if the full upload was yes, then the full upload happened, and then the last load timestamp was set to a particular value. But in case the incremental load was to take place, then it picked up the last load timestamp. Yes, any questions?
Hello, sir. Can you hear me?
Yeah.
Yes, sir. Just one question. You showed that data flow. In that data flow, you are doing a validation, right?
Right.
So as I just joined late, I just wanted to know what is happening inside that validation.
Right. So the validation, actually what happens is the same as a SQL is null. Right. So what happens is that you basically look up the value of the surrogate key here in the validation.
But sir, in the table comparison, we are also, it's a kind of a lookup, if I'm correct, right?
So in the table comparison, it is also a lookup. But why we used a validation transform before it is because in order to reduce the load on table comparison.
Okay.
Because
Okay,
table
got
comparison
it.
uses a lot of memory.
Yes, yes.
Okay. Now the second thing was that I wanted to do the initial load also in the same data flow.
So when you're saying initial load, you mean the full load?
Yeah, the full load.
Or Okay. Okay.
So what happens is when I do the initial load in the same data flow, right? So I'm taking it up somewhere here. So what will happen is if I do not keep this validation transform, querying in the validation, because this will go very, very fast, right?
Right.
Otherwise, it will go through the table comparison each time. And this will take a lot of time.
Got it, sir. Got it. Thank you so much.
Okay, so later on, once we came back here, then in the SQL transform. So when you do the SQL transform, that's why I said that this SQL is going to be you do a composite key match. When not matched by the target, then it's a straight and insert, right? But when it's matched, then you're updating it here. So this update portion is what is going to be the table comparison, which takes in a lot of memory. This insert will happen really, really fast. Because before doing the insert, we dropped all the indexes and all also. So here I'm giving you the script, which is also going to be that in case you don't have an option, in case you do not have an option of using a SQL script, then you can use a template of this particular script. Because it can happen that in your particular case, SQL procedures might not be allowed. Right. So in case the full upload is no. So I mean, I set up the variable and parameter here, and if the full upload is yes. So if the full upload is yes, then what happens is, then I simply insert the database, the default values. Okay. Which in terms of your dimension data load, so I will actually show people here that in terms of dimension data load, here I'm declaring a category. If exists, select stop point, print default value exists. Otherwise, it prints in a default value here. This is the same thing which is happening here. Is it clear?
Yes, sir. It's clear. Thank you.
Otherwise, what happens is that you look for the last load timestamp. Then I pick it up as a variable, as a parameter, and then I put it into the data flow. Okay. And then I pick up all the values where it is greater than the last load timestamp. Right. Okay. So here it is. This is how the initial and the incremental load took place. Now, in the case of dimension tables, which are type 1, right? That's what you asked me, right? So in case of dimension tables, which are type 1, simply use this because after the table comparison, either you'll get an insert or you'll get an update. In case you get an update, then you simply transfer it. But in case you get an insert, then you use the key generation and then load it onto the database. Is it clear?
Yes, sir.
Okay. Similarly, in case of type 2 dimension, sir, what happens is query transform, table comparison. I have the history preserving. Again, use the same combination of map, key generation, and map and update. Right. So it's the same combination which is actually going to do it. So I'm going to be doing it to the SQL transform. Just use these templates and you should be through. So with this, Sumit, I've come to the end of my, I've come to the end of my demo. You can ask me whatever questions you have. We can link it up with SQL and actually explain it to you. So if you understand SQL, then our team can actually explain it very, very quickly. So basically, we are basically looking at how to handle merge transform within data services. That's what we have primarily looked at. All right. And then, and take it up. The only attribute is the variation is that how do you handle history making? So history making will use history making transform. Any questions?
No, sir. No questions.
You're based out of UK. I mean, where are you based out of?
I'm actually based out of Netherlands, but nowadays I'm in India on vacation. I'm
Okay,
working in
so
Netherlands.
oh, so that's great. So I thought otherwise Netherlands is way off. So that's why I had given the flexibility. And we want to thank you for the time.
Thank you so much. And just one thing. So I just wanted to understand the purpose of this is demo. So is it like you are providing any trainings, or is it like you are just you have already